Hello, everyone. I'm going to be giving a little lecture on DNS, also known as the backbone of the internet. So, what we're going to cover in this lecture is we're going to go over what is DNS, why does it matter, the hierarchy, a simplified way of how it works, different types of DNS servers, common record types, caching, security concerns, one or two real world DNS issues, DNS tools and utilities, and just a quick conclusion. So, what is DNS? Well, let's start with what it stands for. It stands for Domain Name System. Uh, I've also heard it called Domain Name Service. Technically, it's called Domain Name System. It acts as the Internet's directory service. It maps human-friendly domain names to IP addresses. It allows computers to identify each other. And think of it like, and this is an old analogy, but think of it like a phone book. Okay, so if I'm using a phone book, I want to look up the name of a business, or if I'm using the white pages and I want to look up a person's name, I go to their name and then I see their phone number, right? So with this system, I don't have to remember the IP address for google.com. I just type in google.com and the DNS server essentially looks it up for me. If we did not have DNS, we would have to remember numerical IP addresses for every website you want to visit. Yeah, that'd be a pain. And DNS is one of the foundational protocols of the internet. It was developed a long time ago, back in 1983, by Paul Makapetris. Okay, so why does DNS matter? Well, I mean, user convenience for one. It's easier to remember a name than a bunch of numbers. There's also infrastructure scaling. It's, you know, with DNS, you can have load balancing, distributed distributed infrastructure by mapping a domain to multiple IPs. It's essential for certain services, for like email. Uh, like if you don't have MX records, you don't have an email server. And uh, speaking of email servers, well, it does play some role in security, mostly identity verification. You have DKIM and DMARC for email. You also have DNSSEC, right? So what is the DNS hierarchy? And I have a picture on the next page, but we got text here. So it follows a tree-like model. You have the root zone. That's at the very top of the DNS hierarchy, represented by a dot and managed by a root name server. Then you have a top-level domain, such as .com, .org, .net, and country code TLDs like .uk, .jp, .ru. Then you, and of course, you can also have like .biz, whatever. These used to mean something back in the day, like .com was .commercial, .org was .organization, .net was, I believe, .networking. Uh, there you go, right? And there was a theory originally to keep sites, like if you had a commercial site, you have to have .com, right? That got thrown out pretty quickly, I think. No one really follows that anymore. Uh, okay, sorry. Then we have the second level domains that's directly below the TLD, such as, example in example.com. And then we also have optional divisions within the domains like www, mail, or blog, right? So here we go. Okay, get my little pen tool. So we have the root. This is the dot. This is actually hidden by web browsers. So when you do, we'll just come down here real quick. When you do example.com, to the right of .com, there is a dot. Fun fact, put it in your web browser. Go www.google.com and then put a dot there. It'll still go to it, right? This is the root. You never have to. I mean, this is just a simplified overview of DNS, so I'm not going to get into it. Might in advanced videos, but like if you're working with Windows Server at like a giant organization you're working with, it's essentially everything to the left of this dot you worry about. Anything to the right is just, knowledge for knowledge's sake, but it's still important to know. Okay, so you got the root. Then you have, your top level domains, .net, edu, com, .net again, .gov, right? Then you have your second level domains, like example, right? Then you can have subdomains like cluster.example.com, mail.example, www.example. That www, that's World Wide Web.example.com. So this is the thing. This is an old thing. Most of the time when you put in a website, it'll prefix it with www automatically. Web browsers will do that. Okay. So you don't really got to worry too much about some of this, but like mail.example.com, that's obviously your mail server, right? Cluster could be a cluster of computers. You can do whatever you want for subdomains. Like I have like blog, obviously not example.com. I'm just not sharing the site, but like I have like blog.example.com. I have like videos.example.com, mail, which goes to my webmail portal, right? Or like uptime.example.com. And then you can have hosts. So, node1.cluster.example.com. I'm not really gonna get into the host thing. For all intents and purposes, you don't have to worry too much about that, unless you're a Windows Server admin. All right, let's go to the next slide. So how does this actually work? Well, you go to your web browser, you type in, let's say, www.google.com into your web browser. You type it into Firefox. The browser will ask the operating system for the IP address. The operating system will ask the recursive resolver, that's your DNS server, whatever you have specified. So if you have never messed with the settings, that's going to be your whatever's supplied by your internet service provider. Or if you did mess with your settings and set it to Google DNS, it's going to ask Google DNS, and the resolver will check its cache. And let's say just for example, this is a .com. So if Google DNS checks its cache and it does not get an answer, it'll query the root server and it'll say, what is the TLD server for .com? Okay. Then it'll query the top level domain server for and it'll get the authoritative server for example.com. Sorry, google.com, example.com. Then it queries the authoritative server and it gets the IP address of example.com, and then the response is returned back to the user cache and you navigate to it. And this happens in seconds. I need to point that out. Assuming everything's configured correctly. Okay. Pretty cool and pretty crazy. So there's many types of DNS servers. Obviously, we just heard about them, right? You have the recursive resolver. This handles all lookup requests from clients. It may cache results to speed up future queries. So, like, most people use Google DNS. Um, if you never configured it and you use your ISP DNS server, I bet it's kind of slow because they're probably using probably sending the queries out in real time. They're not doing a lot of caching. They don't care, right? Because most people switch. Then you have the root servers. These are 13 main server clusters. This directs queries to the correct TLD servers. I want to say like 4 of them are in the US, uh, one's in Germany, a couple in Sweden. You can look it up. Um, these are very important. Okay, if they went down, bad things might happen to the internet for a little bit. And the reason there's 13 is redundancy, right? Then you have TLD servers. They're responsible for, sorry, they're top level domain servers. They're responsible for domains like .com, nor .net, .org, .whatever. Uh, and it'll direct queries to the appropriate authoritative server. Then you have authoritative server. It stores actual DNS records for the domain. It provides final answers, including A, MX, and CNAME records. Now, I know I just said A, MX, and CNAME records. What are those? Well, those are DNS record types. Uh, most common you have is an A or an address record. You just normally call it an A record. It maps a domain name to an IPv4 address. Then you have a AAAA record, or I refer to it just as a quad A record, and that maps domain name to an IPv6 address. You have a CNAME canonical name record. It aliases one domain to another. So, for example, if I have blog.example.com, I can alias it to point to example.wordpress.com, right? Then you have MX, Mail Exchange. It just specifies mail servers for the domain, pretty standard. You have a text, records. This just holds text, not that hard, right? Now, it's commonly used for SPF, DKIM, DKIM, and domain verification. And then lastly, we have NS, name server. It specifies authoritative DNS servers for the domain. So, talk about some, I guess, DNS things. Like you've heard me say caching. What is DNS caching? Well, caching can reduces DNS traffic and speeds up website loading. DNS responses are cached at multiple layers. So we have the browser cache, very short term, local cache. That's why a lot of troubleshooting tips, you're like clear your browser cache. That's why you're clearing not only your cookies, but you're clearing your DNS caches. You have your OS cache. It's a system-wide cache. For example, like Windows, right? You can also clear your DNS cache on Windows. And then you have your resolver cache, which has a longer time to live, time to live. So time to live is essentially determines how long a record is cached, because you want them to be you want DNS records to be refreshed occasionally, right? You don't want example.com to point to an IP address for like in at least for this lookup system, you don't, or for this DNS system, you don't want it to be live for like years, right? Because, you know, user forgets to or renew the domain, someone else takes it, right? You want it to refresh. Um, Now, caching can cause propagation delays when DNS records change, though. I'm going to be honest, as someone who's a little bit older, that used to be a thing. Okay. I remember when I was a young adult, well, I was a teenager, maybe 17, 18, and I bought my first virtual private server, my first domain name, set everything up on my VPS to host my forum for me and my friends, and set the domain. I believe it was GoDaddy at the time. Pointed the domain IP address, pointed the or linked the domain to the IP address essentially. Went to go to the domain and nothing because it has to propagate, right? Traditionally, it could take up to 72 hours. Realistically, though, in modern times, I have not seen it ever take 72 hours. I have not seen it ever take 24 hours. Unless there is some reason for that, right? Like some reason outside of the technology, like oh, we need to go through and like approve this change and do all this stuff. From a technical level, I have made DNS changes and it is propagated within 20 minutes. Okay, this is kind of an old thing, but it's useful to know some of these things. Okay. All right. Well, we can't talk about DNS without going over some DNS security concerns. And I need to stress this is not an in-depth lecture. May break it off into more looking at more niche things on it, but this is just an overview, okay? So some DNS security concerns. We got DNS spoofing, also known as cache poisoning. So this will inject false DNS data into a resolver's cache, and it may redirect the users to malicious websites. So when we say injecting false or malicious DNS data into a resolver's cache, we can say several things here. We could say the actual DNS servers, right? That does not happen that often. Rarely happens. Excuse me. But most of the time when we say cache poisoning, as far as you, the end user, is concerned, we're talking your web browser cache or your OS cache. Most of the time it's the OS. Like if I had a malicious script to make, I don't know, google.com resolve to bing.com, I don't think you'd be happy. There is some other DNS security concerns though. There's distributed denial of service attacks on DNS servers. It can overwhelm DNS servers and make sites unreachable. This happened to Dyn in 2016. And if you can't reach a DNS server, you can't pull down the IP address associated with the domain name. We also have DNS hijacking. You can redirect DNS requests to rogue servers. There is some mitigation though, right? We live in 2025. We have DNSSEC. It adds cryptographic signatures to ensure data integrity. So that right there, just off the top of my head, can stop spoofing and hijacking. I want to say more so hijacking. We also have DOH or DOT, or DOH/DOT. It encrypts DNS queries to prevent interception and tampering, which is also very useful. It's also a privacy thing, if you think about it. You want to encrypt your DNS queries. Do you want your ISP knowing what websites you visit? Well, I'd look into that. All right. So again, real world DNS issues. We have the Dyn attack in 2016. Just a short overview. Distributed denial of service attack targeted DNS provider Dyn using a botnet of IoT or Internet of Things devices. This botnet sent essentially terabytes of data. I think it was a petabyte actually. It sent a lot of queries, all right, and it caused Dyn to go offline, and it took down major sites because no one could reach them. I mean, Twitter, Netflix, Reddit was down, GitHub was down, a lot of things went down. um, we also have, propagation delays. I spoke about that. We also have misconfigurations. I kind of questioned why I left that up, but 90% of the time, the issue is not other companies or technology, it is the end user, and that includes us IT people, as someone who makes mistakes too. I can say that. So I would say this is a real world DNS issue. If you create incorrect records and you don't know what you're doing, you may be sending emails to a black hole. You may be making websites inaccessible. You may be making internal websites and maybe internal email, if you use that, inaccessible. Because DNS is not just, again, overview. I'm getting in the weeds. I love talking about this stuff though. But DNS is not collect my thoughts. I mean, you can set up a DNS server, right? Uh, Large companies do it. If you use Windows Server, even if you're like a Linux shop, you have, hundreds of computers, printers, all that, an internal website. You're running your own mail server. You're probably going to be running your own DNS server. So misconfigurations is more towards the enterprise side, not so much if you're just regular Joe Blow watching my video, wanted to learn a little bit about technology. But I suppose misconfigurations could affect you if you set up your own website, but a lot of times you go find a guide and you just go through it step by step and you're golden. So I wouldn't stress too much about this. So just some quick DNS tools and utilities if you don't know, if you want to learn about them. Okay. Um, on Windows, we have NS lookup command line tool, very basic DNS query tool. Nothing is stopping you from playing with it right now. Just open up command prompt and do it and use it. You won't hurt anything. Don't worry. For Unix, Linux, we have dig. We also have host, which is another simple DNS lookup utility. We have some online tools. Those are important. My personal favorite of all time is MX Toolbox. Okay. We also have Google Dig and DNS Viz. I don't use those that much, but MX Toolbox is also free. Go on it, play with it, learn, explore, right? It's just DNS queries. You're not going to break anything. Why would you use any of these utilities? It's useful for diagnosing stuff, you know? All right, so quick conclusion, my DNS overview. It's a core component of the internet's infrastructure. Without it, it would be hard to use. It enables human-friendly domain names to function. On the flip side, misconfigurations or attacks or malicious actions can have widespread effects on the internet. No, really, you think? Understanding DNS, though, just the very basics, it could really help you with troubleshooting networking issues, right? Because if you just know how DNS works, and let's say you're just got hired for an IT support role, right? Here's an example. If you know how DNS works, just the basics, and you have a user who says they can't access a website, like, hey, I can't get to Google. And just knowing about DNS, knowing that it exists, you can sit there and you can go ask some questions. You can be like, okay, you can't get to Google. And you go through, you verify they're actually using a web browser, right? I've had users try to use the file explorer to navigate to websites. Yeah. Anyway, so assume I'll play through this scenario for a minute or two. So, or three. So assume they're using a web browser. Hey Andrew, I can't get to Google. Okay, well, um, I know that you have a shared drive that you use to put all your work in. Can you access that? Okay, you can. Cool. Can you go to? Okay, so you can access that. What happens when it comes up? What error message do you get? Right. Now, to be completely honest, if I'm the one troubleshooting this and they say they can't get to a website but they have access to internal resources still, I just walk them through how to clear their DNS cache just as a first troubleshooting step. Probably about 50% of the time it fixes it. If that doesn't work, then I ask them to navigate to essentially figure out what their DNS server is set to, right? And yeah, it just, knowing this stuff, it's fun. You know what? It's free knowledge. Enjoy it. So that's it for this one. Future episodes, I may do some more dives on DNS. I slapped this presentation together in about 30 minutes, honestly. Reciting some of it from memory. I'm positive about like 98% of it's completely correct. But yeah. Uh, but I might dive more. I might talk about some of these advanced DNS features like DNSSEC and stuff. I mean, that's kind of that gets into like enterprise, and I mean, if you need to know about that, you can go get training for it. Anyway, I hope you enjoyed this little mini lecture. It was almost 30 minutes, but hey, it was a mini lecture. And you know what? If you have any questions, put them down in the comments. Uh, I'll answer them. Anyway, peace.